Okay, welcome AP Chem students. This video is going to be a short video, I hope, about the structure and acid-base properties of an acid or the acidity of a binary compound. One of the things that AP Chemistry will want you, the AP test will ask you about is to take a look at structure, especially with the new design. It is a lot more about structure and pictures and making some inferences based on that structure. So if you were asked to determine the acid-base properties of a binary compound, two factors really are important to determine, how acidic a compound is. The first would be bond polarity, and the second is bond strength. So if we take a look at something like methane, and I'm going to draw just the structure here of methane, okay? There's tons of hydrogens there all around that carbon atom, but this is not an acid. And the reason why this is not an acid is because there is a strong carbon-hydrogen bond there. This is also this is also a nonpolar compound. So there is no protons being donated in a structure like this. So when you're looking at the fact that it is nonpolar, that bond strength between the carbon and the hydrogen is very, very high. That is not going to be an acid. But if you take a look at something like HCl, which looks like this, okay, now that bond strength between the hydrogen and the chloride is actually very low. It's going to want to dissociate completely in water. It's definitely a polar molecule. There's a lot of things that are going into play there. Also, and I believe that you learned in your Renee McCormick videos earlier, is that you really should know this series, this HF. I believe I'm doing this by the periodic table, although I don't have one right now in front of me, but I believe this is the order of the halogenated acids. This would be the top of the periodic table here, the HF going to HI would be at the bottom of the column on the periodic table. And what is interesting is that if you were to look at this is considered to be a weak acid. And the AP board likes to talk about HF a lot as a weak acid. The rest of these here, so these are all strong acids, and you should have this memorized. You should know those strong acids. And of course, there's more than those three, but those are the three halogenated acids that are strong. HF is weak. And the reason why HF is a weak acid is because fluorine is so electronegative that it is able to hang on to this hydrogen stronger than the hydrogen bonds for any of the other halogens, chloride, bromide, or iodine. So these have a weaker bond here. This has the strongest bond. The HF has the strongest bond. So for that reason, this is going to want to stay intact more so than these. These are going to want to break easily. So they have a very low bond strength, okay, as stated before. So you should be aware of that. Also in the Renee McCormick video, they talked about the structural effects of the oxyacids. So I just kind of want to make sure that we review this with you. So as you have more oxygens, you're increasing the electron density of the molecule. So as the number of oxygen atoms attached to the chloride atom increases, they become more effective at withdrawing electron density from the OH bond, thereby weakening it and making it more polarizing. So as we look at, let's just do this, as we look at this acid, which has just one oxygen, okay, there is a much stronger hold, if you will, on that hydrogen atom than here. Okay, and the reason is because the increased oxygens make that more polarizable. Therefore, this right here is a weaker bond, which means stronger acid. And if you would recall, this is perchloric because it is coming from the perchlorate anion. So perchloric acid, if you would remember, is one of the 6 that are of the strong acids that you should memorize. All right, moving on. Also in your textbook, there's a little bit about, the oxides, what we call acidic oxides, or sometimes they're called acid anhydrides. And when you take a look at these bonds, like the SO2, the NO2, the CrO3 bonds, and if they are reacting with water, you are making a acid, okay? So those are called acid anhydrides or acid oxides. That OX bond, which that X could be any of those anions, okay? So it could be the sulfur, the nitrogen, the chromate. That bond is strong and covalent. So since it's strong and covalent, when an oxide dissolves in water, an acid solution will form, and typically it is, depending on what the anion is, but typically it will be a weak acid, but there are some exceptions like the HNO3, of course, is a strong acid. So just kind of take a look at that. Also, your book will talk about basic oxides, and we learned this in honors chemistry too. If you would recall that whenever you have a metallic oxide plus water will make a hydroxide. So we learned that in our first year course. That's usually typically an ionic bond. And the oxide ion has an affinity for the protons and reacts with the water then to produce those hydroxides. So that's something also to take a look at and make sure that you review with your report or with your textbook. Okay, and finally, I am going to talk about just very quickly Lewis acids and bases. They are not a part of the AP test, nor will they be a part of the test that you will have on this chapter 13 and 14 test, but it is important for you to just at least understand what they are or hear what they are, because they'll be huge when you get into organic chemistry as well. A Lewis acid is an electron pair acceptor, and a Lewis base is an electron pair donor. So if you were to taking a look at any H plus has no electrons. So it can accept electrons from typically somebody that has, a lone pair together. That's typically what happens, and that would be called a Lewis base, where it is an electron pair donor. And what happens is that you would end up making, this ammonium ion, like this, where these lone pairs will actually just connect with that hydrogen ion, and that's a Lewis acid or base. The interesting piece about it is that it doesn't even need to have hydrogen ions to be an acid. Lewis acids and bases are like the broadest category of what we would call an acid and a base. Here you would have something like aluminum, and you would end up having 6 hydroxides. But what happens is you end up making oftentimes, and this is what you did in your KEQ lab, you end up making something called a complex ion. Okay. Again, they're not really, they are in the AP test, but the amount of complex ions is pretty minimal. But they can show up. So I don't think that you really need to worry so much about complex ions. It's part of the fact that we can't get through all the curriculum, and we kind of have to be okay with, just understanding a little bit about it, but you don't have to know the full piece of that. As well as I said, Lewis acids and bases will not be on this chapter 13 and 14 test, and nor will complex ion formation be as well. Just basically explaining this to give you guys a little bit of background. I hope this helps, and I wish you luck.